right, we're going to go on to the next part of our normal model. And we want to learn how do we handle a situation that is not a whole number of standard deviations away from the mean. Everything that we've been doing, the percentages and such, have been, one or two or three above or below the mean. They've been falling exactly on a standard deviation. Well, I'm sure that you would realize that in real life, that's not typically what happens. So we need to learn how do we handle that when it's not perfectly on a whole number standard deviation. So here's an example. All right, we're going to talk about this girl. Her name is Ileana, and we're going to say that she is transferring from our school. And we, of course, want to then transfer her grade from Lanier High School to Aledo High School. Well, Lanier High School has a much different grading system than we do. They have a 6-point scale. Okay, they don't have the 100-point grading scale that we do. So, we're going to talk about the facts that happened in her statistics class because we want to put her, um, we want to give her the same comparable grade here in Aledo that she had in Lanier at that different grading scale. So here we go. So if she gets on a 6-point scale, the average statistics grade was 5.1 with the standard deviation of 0.45. In Alito, however, the average is 86 with a standard deviation of 6. So how would you, if she made a 5.6, so that's what she makes at Lanier. She's making a 5.6 last semester at Lanier. What does that then calculate to at Aledo? All right, so I want you to think about that for a second. Let's see what you come up with. Well, most of the times, my students will think about that proportionately. Absolutely. That is what you have been learning for 12 years, okay? How to think proportionately, direct relationship, and it may have looked like this. You can set it up different ways. But that proportional relationship would give her a grade of 95 here in Aledo. The problem with that is that a proportional relationship says that the grades are distributed uniformly. So let's think back to what that looked like. Remember how this uniform distribution looked when we first started this idea? That would say there's the same number of F's of the grading scale 1 to 6, the same number of ones and twos and threes, fours and fives and sixes. Each grading scale item got the same amount. Well, I don't really think that that's probably the case. I think that the grades are probably distributed with more people around the center, and the farther away you get from the center, then the less likely. So that then looks more like a normal model. So the grades are probably distributed more like this, okay? Not uniformly. Therefore, proportional relationships, no. That is what sometimes we're instinctually wanting to do because math has taught us that for 12 years, but not if we want to do the same relative relationship at Lanier to Aledo. So let's set up this normal model. Here we go. So there's our standard deviations. Okay. We had 1, 2, 3 below, 1, 2, 3 above. So at Lanier, the average is 5.1 with a standard deviation of 0.45. So I added up the 0.45 each time. Okay. And then I subtracted down the 0.45 each time. All right. And then at Aledo, our average was 86. with a standard deviation of 6. So I added up 6 each time and I subtracted down 6 each time. And that's how I got the distribution of the scores at Alito. All right. So now let's locate where Ileana is in the spread of grade distributions. And she is about right here. So here's 5.55. She got a 5.64. So it's somewhere in between 5.55 and 6. So it's going to be somewhere in this location. And I don't know exactly because that's not a whole number above the mean, then I cannot give her, I can't say, oh, she got a 5.55. Well, that's a 92. Okay. I can't do so. Now I have a situation where I want to find out exactly how many standard deviations above the mean she is. How do you think you could figure that out? So, in class, I'd have my students discuss this. How can I figure out how many standard deviations above the mean this location is? Well, hopefully you understand we need to subtract to see how far away we are. So we're going to subtract 5.64 minus the mean, and that tells me that this is 0.54 above the mean. 0.54 above the mean, okay? But how many standard deviations is that? Well, if you divide by the 0.45, that would tell me how many of those standard deviations she is above the mean. So if I divided by 0.45, that's 1.2. And look at how I located that. Look, she is about 1.2, 1 and then point and 20% up, 0.2 standard deviations above the mean. So at Lanier High School. So then we want to put her 1.2 standard deviations above the mean at Alito High School. And so that's how we then come about that thought process. Okay. Now I get students every year ask me, is that how they really do it? And that's no, they don't, but that would be the best way to, but they do not. But anyway, so let's just kind of answer some facts. Okay. This idea of how many standard deviations you are above or below the mean is called a z-score. In fact, I think that was down at the bottom. I just kind of skipped over that. Yep. The z-score is the number of standard deviations above or below the mean. So she is 1.2 standard deviations above the mean at Lanier High School. Okay, so z-score. How many standard deviations? The number of standard deviations you are above the mean or below the mean. So a z-score of 0 means that you are located at the mean because you are 0 standard deviations away. What about a positive z-score? Because we have positive z-scores and negative z-scores. So a positive z-score are going to be those that are related or located above the mean. And then negative z-scores, of course, are going to be those ones located below the mean. Okay. So here's how you had figured out Ileana's location, by the way. We took her score and subtracted away from the mean of the class and divided it by that standard deviation. And that is how we get that z-score. That is, in fact, a standard formula that you have to know how to get a z-score. So I've got a song for that. And so it's a song that you may be familiar with. Let me see if I can't find that for you. I didn't have that pulled up. So let's see if I can't pull up our StatCat song list. That's in our normal model section. And so there's multiple parts to it, okay? And the second part we won't learn actually for probably another week or so. Okay. So it has something else in this song that you won't necessarily understand, but we'll get the first part that we like down.
X minus the mean over the standard deviation. X minus the mean over the standard deviation. Inverse norm of the area below.
So you don't know this
Inverse
part yet.
norm of the area below.
We'll get to
Inverse
it
norm of the area
later.
below is the z at that spot. X minus the mean over the standard deviation. X minus the mean over the standard deviation. Inverse norm of the area below. Inverse norm of the area below. Inverse norm of the area below is the z at that spot.
Anyway, you can see a z-score of 0 is right here, negative below, and positive above. Okay, so x minus the mean over the standard deviation. So z is that z-score. It's also called a standardized score. X is that context, like what Ileana got, her grade, context value. Mu is that mean, and sigma is that standard deviation. So we have our x minus the mean over the standard deviation, x minus the mean over the standard deviation. And so we'll work with that here in a minute. But remember that Ileana had a z-score of 1.2. So her z-score was 1.2, and we had already calculated that. So that's how far away she is above the mean. Well, now you can translate that to anywhere else if you know the mean and the standard deviation. So since Ileana is 1.2 standard deviations above the mean at Lanier, I'm going to place her 1.2 standard deviations above the mean at Aledo. And so that using Aledo's mean and using Aledo's standard deviation. So Aledo's mean was 86 plus 1.2 of Aledo's standard deviations gives her a grade of 93.2. So she has a 93 for statistics, not a 95. So if you're one of those grade grabbers, then you like that we did this process instead of the proportion process, okay? So there you go. That is how we equate one location in one situation to the same location in the other location or in the other situation. So here we go. Let's do these and then see how these things compare. We have a student who had two quizzes in the statistics course. The first quiz, he got a 30, the mean was 32 with a standard deviation of 8. Hopefully these weren't out of 100 points. And the student got a 44, so I can see the student was above the mean, so that's good. The second quiz, the student got a 28, which is above the mean of 23 and the standard deviation of 3. On which quiz did this student technically perform better relative to the rest of the class, relative to that mean? So, do you see the problem here? We have two quizzes which have different means and different standard deviations. So they may even have different point systems, okay? And we want to compare how did he do when I'm comparing these different point systems. So what we need to do is find that standard score at each location. So that's what I do here. So I've got so on the first quiz, so I've wrote out the facts here. And so at on the first quiz, 32, and the standard deviation was 8 and the student got a 44. So look at this z-score. X minus the mean over the standard deviation. X minus the mean over the standard deviation. So that X is the context value. That's 1.5. So that student is located 1.5 standard deviations above the mean. All right, well, let's see how this student did on the second quiz. The mean on the second quiz was 23 with a standard deviation of 3, but the student got a 28, which is above. So we do our z-score, which is x minus the mean over the standard deviation, x minus the mean over the standard deviation, and that's 1.67. So if you are thinking about a normal model, okay, then this student, you know, 1.5 standard deviations above the mean is here. 1.67 standard deviations above the mean is higher up. So the student did better on this quiz that was more standard deviations above the mean. And so that's my decision. So here we go. It says the student did better on the second quiz relative to the rest of the class, okay, because the student was more standard deviations above the mean. On the second quiz, 1.67 versus 1.5. Okay, so I stated what he did, I stated why it was better, and then I gave the statistical evidence of those numbers. Does that format sound familiar? We have done supporting format in that way before. Okay. Next situation. Read this one. It's about a married couple. They're employed by different departments. Okay, and we want to see who is higher up in his or her respective departments, even though they may make different hourly rates. So, read that. Try that. Pause this video and then see what you come up with. All right, so after hopefully you paused and then put down all the facts, here we had the husband's mean and standard deviation. The husband made, so the husband's context value was 14.60. So the husband's x minus the mean over the standard deviation is 1.5. So he's 1.5 standard deviations above the mean. Now the wife's making more than the husband hourly. She makes 15.75. But if you look at the z-score, x minus the mean over the standard deviation, she's actually not as far up in her department as the husband is. So it's interesting. Even though she makes more, she's technically, relative to her peers, she's not as high up in the department as the husband is in his department. So the husband is paid better relative to his department than the wife because his hourly rate is more standard deviations above the mean. And then I gave statistical evidence 1.5 versus 1.25. All right. That's what you do when you have a piece of data that is not located a whole number of standard deviations away from the mean. That is how you will compare two sets of situations that are not on the same scale. You know, comparing apples to oranges, comparing the husbands to the wives in different departments, comparing the quizzes, two different quizzes that are on different grading scales. So that is the important thing about standardizing this with a z-score so that we understand what that means and how we can compare items. All right, there is the end of your notes on z-scores.